Okay guys, this is my first video on something else than physics, and I'm really excited about it because working with 3D graphics is really dear to my heart. I cannot explain why, but I find it really cool. So I like learning about it, and I keep learning about it. And today we will try to recreate this sphere that you see over here. So this is a 3D sphere that both rotates, as you can see, and pulsates, as you can also see, okay? And after you've seen this, we will close everything and start from scratch, and hopefully I will be able to recreate this, okay? So the story with me and 3D graphics is that I used to have a job in which I met these architecture people who do research in architecture, and I was assigned a project through which I got introduced into 3D modeling, and I was trying to render graphics on a web browser for that project, and I didn't know what to do. And eventually I learned about Three.js, which is a 3D library written in JavaScript, and it's used to create 3D graphics in a web browser. And long story short, I ran into Bruno Simon's lessons on Three.js. Shout out to Bruno Simon, by the way. And after learning about Three.js, I wanted to go further into this. So gradually, I learned about the existence of game engines. I had no idea about them, and up until maybe 2020, I did a few things with Unity, but I never really liked it. I don't know why it didn't click with me. And eventually discovered Godot, which is, my understanding is that it was created by some people in Argentina. So shout out to Argentina as well. And I started playing with it just a month ago. And this is one of the first things I was able to do. And after learning about Three.js, I kind of built the intuition needed to make this. So hopefully I will do a good job in explaining to you how to make this. So let's close this. And I'm not going to close Godot for now. I want you to become aware of this website, first of all, okay? Three.jsresources.com. For those of you who are total beginners in 3D graphics, the same materials used for Three.js to create web graphics on the web can also be used in Unity and in Godot and in any type of 3D graphics that you want to play with. So anyway, in this website, they have everything you need. Okay, it's Three.js focused, so they have learning resources. If you press this, it highlights the available lessons on anything related to Three.js, tools and extensions, website, and so on. In our case, we are interested in materials, okay? And these materials are going to be applied on, let's go back to the sphere. I switched it off, okay? So when you create a sphere, it comes, it's usually white because it has no materials applied on it. You can imagine a material as sort of like a cloth that is wrapped around a physical sphere. So the same idea is applied in graphics. You have an image pretty much that is applied on top of a text, on top of a mesh, I'm sorry. And a mesh is just points on a sphere or points on a cube and stuff like that. I'm going to talk about that later. But anyway, what we will be using is this website, okay, 3D textures. Okay, so you click here and you visit the website. These are free. They are under the Creative Commons license, I believe. It's mentioned somewhere in this website. I can't see it right now. Anyway, I cannot see it, but you can play with it later. So these are free. It's mentioned here. So these are free PBR textures. PBR stands for physically based rendering, which means that these materials are designed to mimic the physical world. So they reflect light if you apply light on them in your game engine. They absorb light and they have the similar texture as the physical material, etc. So for this video, we will be using you see that there are dozens of materials you can use. And in our case, we will be using the marble material, okay? The marble materials, I'm sorry, because there are plenty of them. And especially this one. I liked it because it reminds me of the planet Mercury for whatever reason, okay? So if you go in there, and by the way, you can also use other materials as you like. I mean, you can play and experiment with anything you want, but we will be using this. So if you click on it, it says that it's a free seamless texture, 1024 by 1024, that's pixels, with the following maps: diffuse, normal, displacement, roughness, and ambient occlusion, okay? And all you have to do is to press download all the maps. Okay, I did that, and I'm going to show you. Okay, actually, let me show you one more thing. This takes you to Google Drive. Okay, so all you have to do here is how did I do it? Okay, I cannot download from here, or maybe I can. Yes, you. Sorry, I don't know why it switched to Greek. But anyway, you download from here, or I think if you are logged into your Google account, you can download the whole folder, and it's going to be downloaded as a zip file, and you can unzip it and get access to these materials. Okay, and let's see these materials. I downloaded them over here, so you. So I downloaded them over here. So you see the zip file, and if you unzip the zip file, you get all these materials: ambient occlusion, base color, height, normal, and roughness. This one over there just shows you what the material will look like if applied on a sphere. So you don't use that really, so you can delete it pretty much. Okay. And all you need are the ones that come with an underscore and then names such as ambient occlusion, base color, height, normal, and roughness. Right? Now, okay, we've seen that. Here is the live of the sphere. So to go here, you have to press play. I'm going to show you later. So anyway, let's close this, and let's do, we don't want to quit Godot. We need a new project pretty much. Let me find, I'm still learning my way around, guys. I'm sorry. So I don't want to quit. I want a new project. How can I do that? Export as, okay, closing now, project, export, tools, reload, quit. Yes, quit to project list. Okay, that's the one. All right, so that's my sphere, as you can see, and that's another project I'm working on. By the way, this is Godot 4.4, and there is an update available. I can do that later. So for now, let's create. You press create, okay, and then let's browse. I want everything to be here, workspace, and then projects, and then we will select this current folder, and we will call the project Godot, and then 3D sphere, and then let's name this YouTube, I guess, okay, because it's for the YouTube lesson. Okay, let's press create, and create brings you to this empty world, okay. And to start the project, okay, I'm still learning, so I don't claim to be an expert, okay. So the first thing we will do before we do anything, we will come to this folder, marble, gray, etc., and we will drag and drop. Here on the bottom left over here is the file system, meaning that you put all of your assets. When I say assets, I mean materials, for those of you who will make games, 3D models, etc. But anyway, for now we have materials, so you can drag and drop here, okay. And hopefully this will work. It did, okay. So these are our materials, okay. And if you click on it, you can copy absolute path. And where can I open a text editor? Let me open a simple text editor. Okay. So actually, new document. Okay. So yes, if you right click on any material over there and do copy path, you get the path to that material, which we will need when we create the sphere. Okay. Now let's press delete. Okay, these are our materials. We are done with that. You just drag and drop. Simple as that. Now you create a new 3D scene. So you create scenes here. So the idea about Godot is that it uses nodes and scenes. Okay, so each node can have a lot of children nodes, and each node can become its own scene, and scenes can become parts of other scenes, and so on and so forth. But this is simple, so just do 3D scene, you get this node 3D. We can rename this to, just right click on it, and you can rename it to sphere 3D. Okay, and then we need to add the following to this node. Okay, so this is just a node. It's this thing shown over here. Okay, so first of all, we need a mesh instant 3D. How do we do that? You add children to this 3D node. Okay, so you can do this by pressing this plus over there on the left, or you can just right click and then add child node, and then it gives you this search bar, and you can search for what you need. We need a mesh instance 3D. Okay, let's do create. And by the way, I forgot to mention that if we click on anything here on the left hand side, we get on the right hand side, we get an inspector, okay, where we can transform. For example, let me show you. If I go to the editor and drag this, okay, I can move it, and you see how things changed there. So what I did here is to move the node 3D. Okay, let's reset. Okay, and if we do mesh instance 3D, we can play with the mesh instance 3D. For now, it has nothing in it. I will show you what we need to do to make a sphere. But the mesh instance 3D also can be transformed. So if we click on it, we can move it as well. Okay, we can move it up. We can rotate. Oops. And yeah, let's reset. Okay, you saw the rotation over there. Nothing happens because this is an empty space, like nothing is in it. Okay, we also need, before we do anything with the mesh instance 3D, we also need a camera 3D so we can see things. So camera 3D is the next thing we need. So create. You see that these nodes are added as children of sphere 3D. Okay, so you see this is our camera 3D. We need to transform it so we can see the sphere, but we can do that later. And we can also add a directional light 3D. So there is light in the scene. Okay, so actually, instead of directional light, which is a light that is kind of like a flashlight pointing towards something, let's do an omni-light. Okay, omni-light 3D means like it creates a scene in which the light is illuminating from everywhere, just like daylight, for example, inside the room. Okay, so let's do that. So, okay, we have light. And what else? Let's set the mesh. Okay, so let's start with there. I hope all this makes sense so far. So to add a mesh, okay, mesh instance 3D, as I said, comes empty. Okay, in order to see anything on the screen, we need to add, for example, you can add a new cylinder mesh. Okay, so that's your cylinder. Okay, we don't need that, so let's undo just by pressing that button there. So we need a sphere as we agreed. So where is the sphere? New SphereMesh. Okay, that's the sphere. Okay, and then this comes with various options over here. Okay, so for example, it has a skeleton, but we don't need that. Surface materials, geometry. I'm trying to see whether there is a wireframe we can see. Global illumination, visibility range. Okay, I can't see it over the right now, but anyway, this is our sphere. We can move it and so on, but let's go back. Now, how do we apply these materials? So the materials, remember, are over here. The textures are over there. So to make a sphere have a texture or color, etc., we have to press the sphere over here. So by clicking on the sphere, we make this menu appear, and here is where we can apply materials. Okay, so we can do a new standard material. Okay, so this is the material we need. So we have three options. For today, we will use the new standard material. Okay, so press on that, and now we have material. Okay, now again, click on that material. Okay, I know it's a little bit weird, but I think it makes sense. And we start with the albedo. Okay, so you see where it says texture. So for the albedo, we add the base color texture. Okay, so we drag and drop literally just like that. We drag and drop it there. Okay, and immediately you see the material applied. Okay, that's it. Now, the other textures we have, so we have, remember, we have 1, 2, 3, 5 textures. So we start with the albedo. The next one is the normal map. Okay, and now things are going to be self-explanatory. So for the normal map, we have to click enable. Okay, and now we are given the option of texture. Okay, and we drag and drop. Let me enlarge this so you can see. We drag and drop the normal texture onto the normal map. Okay, simple as that. And down here, Godot informs you of what kind of things or actions were taken. Okay. Now, the next material is the roughness. So you see we have a roughness, and if you go down, you will find roughness somewhere. Should be a roughness map here. Okay. So we drag and drop the roughness texture over there. It didn't work. Let's try again. Okay, so we have roughness now. Okay. The next one is the ambient occlusion. Okay, that one. And we need to apply it to the ambient occlusion. Okay, it's not enabled, so you click enable. And then it allows you to load the texture. So we drag and drop the texture in there. Okay. So we also have an ambient occlusion map. And finally, we have a height map, which you can also apply. So we can apply it here. We press enable, and we drag and drop the texture over there. So we do that. It didn't work. We do it again. This time it worked. All right. What else can we do for now? I want to keep this video simple, so there are some parameters you can change about this material. So, okay, we have our mesh, we have our materials, and is there anything else I want to change here? No. I'm looking for the metallic. Okay, here, this property, you can set it to different values. You see how things change? Watch the sphere. So for a marble, we set this to 0 because it's a reflective surface. But if you make it 1, it now becomes a metallic surface and it reflects the light differently, etc. But let's keep it simple. We can also tweak the roughness. So now it's set to 1. We can make it about 0.8, I guess. Okay, but we have a roughness map. This makes the surface of the sphere look rough, pretty much, okay, just like the word says. And then for the height, let's see if this will work. I want to try something. Okay, for the height, we can change the scale, okay? So you see how it changes the appearance of the albedo texture, pretty much, okay? But anyway, I'm gonna keep it to the default value, so that's fine so far, okay? Now let's go play, okay? Play just runs the project. If something's wrong, it's not gonna play, okay? That's the story with Godot. And okay, it says that no main scene has ever been defined. Select one. You can change it later in project settings under the application category. We're gonna do actually, okay, let's click that out. Okay, the sphere is our main scene. So let's click again and just do select current. And you have to save a scene. And this scene is saved in this directory down here on the left, to the one we started with. So let's call this scene main scene, I guess. And actually, yeah, let's save it just like Godot suggests. Okay, so you just save the scene. Okay, that's it, and we see nothing. Okay, why is that? So let's click out. Remember in the beginning I promised that I'm gonna fix the camera. So the camera is pretty much inside the sphere right now, so we have to drag it out. Okay, so by the way, watch this window over here to the right. It shows you what the camera sees. Okay, so that's a good start. We see something, but it's far away. And by the way, you see this window over there, so you can rotate the camera so it sees the sphere. Okay, I hope this makes sense. You see me how, okay, I rotate the field view pretty much. Okay, so it shows me the sphere from different angles. So let's center it there. I think that's good enough. Okay, that's okay. Other things we can do is if we click OmniLight, we can go to this inspector and let's see if, okay, no, this is the range. I don't need that. I need the intensity, so energy, okay? I think if we increase this, no, nothing happens. Indirect energy, no. There should be a way to increase or decrease the amount of light. You can also change the color, by the way, okay? But we don't want that. We just want, actually, let's try and change it. Okay, let's do it yellow or red. Okay, you see how things change in the screen, but okay, let's go back to white. Okay, I can't figure it out now, and it's not the main point of the video, but I'm just making you aware of things you can do, okay? And another thing we can add is a directional light. Okay, let me show you that option as well. So this is a new node, so directional light 3D, okay? So you create it, and now you have a light that does nothing until we drag it out. And make it point towards the sphere. Oops. Okay, let's go back. Okay, you see, as I rotate it, now it points towards the sphere, so there is a light pointing at the sphere. Okay, and there are cool things you can do with these things, but I'm gonna let you play. And I think now if I do light and in energy, okay, you see how the intensity changes, okay, on the sphere. I think that's cool. So anyway, we have all these things. The sphere is ready pretty much, but I promise that I'm gonna make it rotate. So how on earth do you do that? Okay, as I promised in the beginning of the video, we will also make this sphere both rotate and pulsate. But let's start with the rotation, which is kind of simpler in that whatever you have over here as a node, you can add a script to it, and that script can change properties of that object, okay, of that node. So pretty much all of these properties that you see in the inspector can be changed via script, okay, and let's go see how we can do that. First of all, the script needs to be added to the SphereMesh, okay, not the node, the sphere, because the sphere is the parent node of everything. So if we add a script that's going to make it rotate, nothing's going to happen pretty much. So we need to apply these scripts to the children node. So to do that, to add a script, you can just press this plus button over there, or you can say attach script, okay, and then it suggests a name and it saves it over here on the left where all of our assets are. So you can choose a template, either an empty script or a default. Let's do an empty script, okay? So let's do create. And this brings us to this screen over here. By the way, you can change screens from up here. So this is our 3D screen, 2D, which is empty. So because you're working with 3D, and there are assets you can find. I never used this, I don't know. But anyway, let's go to the script. Okay, and you see how the script starts with the extends mesh instance 3D, which is nothing more than the type of our node, okay? So the first thing we need to add is a new variable, which is gonna define the rotation speed, okay? So that's the angular velocity of the mesh. So we have to press this at and then export, and this will export this variable in the inspector, so we can change the properties from over here on the right. Let's call this, the way to define variables in GDScript is export and then var, and then spin speed, let's call it like that. And speed, I'm sorry. And you can define a type for this variable, and let's define it as a float. And then this is equal to, let's say 0.2. And this is radians per second, okay? So, okay, this is one thing we can do. And then you can define this function called, you don't define it, it's a built-in function, okay? So you see how if you type letters over here, it shows you default functions and variables that are built into Godot. So we need the process built-in function, because this is a function that updates in every frame, okay? And delta is the time elapsed since the last frame, okay? And then we can call this function called rotate, and we rotate around the y-axis, okay? So this is another built-in function that is specific to the mesh, okay? So it rotates the mesh automatically, okay? And all you have to do is to multiply the spin speed. By the way, I forgot to show you that the spin speed is now part of the mesh instance 3D inspector, okay? If I remove this export, by the way, it's just going to disappear. I think it should disappear. Okay, you see, it went to 0, so it doesn't exist anymore. But if we do add export, and then let's set it to 0.3, it should appear back over there. It didn't. Somehow, okay, let's do 0.2, okay. Right, now, we rotate it by multiplying spin speed by the delta time, okay? And that's it. This should rotate the sphere pretty much. If we press play, you see how it rotates, okay? And you see the directional light reflecting off the surface pretty much, okay? Okay, we are done with the rotation. We can do other rotations as well. So let's do rotate Z, and then let's do spin speed, spin speed times delta, and let's do times 0.1, so it doesn't speed very fast. So let's see. We cannot observe it, so let's just keep it like that and see. Okay, you see how it rotates in both directions, which is kind of cool. So we don't need this though. Okay. And by the way, if we change, we can change the speed from here. Let's do 2. I think it's going to be really fast now. You have to always press Command Save before running a scene to have the effect applied to your scene. Okay. So now it's really fast. Okay. So let's do 0.5. Okay, that's good. All right. Now comes the somewhat more difficult part. So how are we gonna make it pulsate? Okay. So when we apply a script to a mesh, whatever we put in that script affects the mesh itself, so the whole object. But to change to make the whole mesh pulsate, you need to apply a shader to it. A shader is something that is applied to each pixel. Okay, and meaning that the shaders work on every pixel of that surface. Okay, so to do that, we have to go to this material over here. Okay, remember the material we were using, and then just press there, and then convert to ShaderMaterial. Okay, and this allows us. This opens this shader over there. Okay, if we press on it, it opens a shader. Okay, with all these properties in there that we can modify, but we will not modify anything. Okay, let's press save. It saved it automatically as a sphere 3D scene, and then as shader. Okay, I don't want to go too much into shaders because it's a long topic, but if you press play, you see nothing changed. Everything's just there. But now what this shader allows us is to change properties of the material itself on every pixel of that material. Okay, so to make it pulsate, we have to apply things in this vertex shader. Okay, so there are two parts of a shader: the vertex shader that changes how the surface itself behaves. Okay, whereas the fragment shader changes how the colors inside that surface behave. Okay, we will not do anything to the fragment shader. We will just introduce I will explain what this is, but let's introduce this uniform. It's called uniform because now it's going to appear as a property over there that we can change. So let's call it uniform float, and then pulsate speed. It's the first one we need. Pulsate speed. So this is how fast it pulsates. And then we will use this function hint range. Okay, and we will set it. We will make it run from 0 to 10. Okay, and set it equal to 2. Okay, so if we save this, it now appears as a shader parameter over here, pretty much. Okay, if we go to the end, it should be there. I don't see it. Yeah, pulsate speed, you see? So we can change it from 0 to 10. So if I do this, if I make it 20, we will be able to change it to 20. So uniforms are variables that change the behavior of the shader and appear on your inspector, okay, in your window. And this shader language is similar to C++, whereas GDScript, as I said before, is similar to Python. So did I say that before? Maybe I didn't, but it's similar to Python, and shader language is similar to C++. Okay, we need another uniform, which we will call it's also going to be a float. Okay, So you see, but those of you who know C++, remember how in C++ you just define variables as float x equals to 9. Okay, now that's a float. So it complains because I haven't done anything there. Okay. It has to be a constant float because outside the fragment shaders you define global variables. Okay, but anyway, so let's go back. Uniform float is the type, and let's call it pulsate strength. So this is by how much it will pulsate. So pulsate strength, and let's make this change hint range, and let's make this change from 0 to 10, and let's set it equal to 0.1. Okay, that's the strength. Okay, so all I did was to define two variables pretty much. Okay, and these variables, because they are declared with keyword uniform, they appear in the inspector over here, and we can change them. Okay, so you see how strength also changes from 0 to 10. Right, and now we have to do things inside this vertex shader. Okay, we keep this as is because this is how internally materials are applied on meshes. Okay, so we keep that as is because we just modified our standard material, which can be created automatically with shader material that can be modified. So we won't change anything that is default over there. Okay, so we'll go to a new line and declare this variable called okay, float. It's going to be a float type pulse. Okay, this is going to be equal to 1 plus, I will type it and explain what this does. Sine, this is the sine function, it's built in. Okay, and let's do time. This is a global variable that is available to the shader, and it's pretty much the time elapsed, just like this delta over there. Okay, it's similar, times pulsate speed. Okay, this means that in every frame, all the pixels on that surface will change according to this time times pulsate, and then you take the sine of this and add 1. Okay, that's it. Okay, pulsate speed plus vertex, that's your vertex function. It's a built-in function, dot y, so we need the y part. Okay, times 5. And what else? Let me think. And then times pulsate strength, okay, which is already defined. And then we need a semicolon because it's like C++, okay? So you see it doesn't complain. So this worked. And then, so this is just a variable, guys, okay? This is a pulse variable. So we add the value 1 plus the sign of this function times pulsate strength. You can experiment with this and have other effects, by the way, okay? Please experiment. So, and then all we do is add to our vertex, which is stationary, plus or plus equals, which is a C++ convention, normal times this variable we created, pulse minus 1. Okay, so this is gonna pulsate pretty much like a sine function. It's gonna pulsate around. Sorry, the surface is gonna pulsate outside and inside pretty much. Okay, let's press save. Yes, we need a semicolon there. See, it complains. Okay, now it's all good. I go back to my 3D scene. You see how the sphere already pulsates, and if we press play, you see how it pulsates. This is kind of wild, by the way, but we can change it. Okay. We can remove, we can reduce the values, but is there anything else I wanted to say over here? I think it's good. Another thing we can do is to add. If we go back to our scene, we can add to another child node and add an environment map, a world environment. I'm sorry. Okay. So if we add that, it complains. Okay. It says node configuration. To have any visible effect, world environment requires its environment property to contain an environment, its camera attributes property to contain a camera attributes resource, or both. Okay, so we added on one more thing. So if we go back over here, we can add a new environment, and then what else? I think that's it. Let's press save and see what happens. If I open the scene, nothing happened. I'm sorry. Let me think. I think this has to be moved up there. Oops. By the way, Command Z takes you back if you make a mistake. Okay. So let's move these over there. And I think now it should work. No, we still don't have an environment. Okay, let's do background, clear color, ambient light, tone map. Let's do sky. Okay, ambient light sky, and then let's do sky again. Okay, you see how things changed. Let's press play, and now you have a dark sky. So this looks like a moon that went crazy. Actually, let's fix these properties a little bit. Let's go to our mesh instance, and let's go to our material, and where is it? Let's see. I want to change, okay, the pulsation speed, okay, and the pulsation strength, not to 0, maybe 0.05. Okay, let's play it here, play it now. Okay, so the moon is rotating and it's pulsating as well. Okay, and another thing you can do, when I talked about vertexes, let's go back to our mesh instance 3D. You can also change the radial segments and rings. So if we increase that, let's do it, let's do 512, and let's do this 64. So what this does, it adds more vertexes on your surface, pretty much, okay? And I think this is gonna change the way it pulsates a little bit. Okay. All right, this is all I wanted to do in this video. I hope this is useful. I've never done this before, and I'm much more comfortable teaching physics than teaching coding. But I like playing with these things, and I find them extremely interesting, and I really love making 3D graphics. Back when I was a kid and I was looking into video games, I thought this is something that a civilian cannot do, that you have to be a god of coding or something like that. But growing up, I learned just a little bit. I guess you still have to be a god to make a video game, but this is a good start, like making 3D graphics, simple shapes, adding materials, and so on. It will get your intuition going, and maybe you can come up with something great. Let me know what you think about this video in the comments. In a future video, I plan to walk you guys through how you go through Sketchfab, download a 3D model, import it into Godot. I will try to do that. And at some point, I might even do Three.js videos, but I feel like it's maybe unnecessary since Bruno Simon has a class that is really great. It's really cheap. So yeah, let me know what you think. Thanks for watching, guys, and see you in the next video.